1, Part 2. Suppose Pair Computing sold an average of 45 phones per minute in 2011. Yes, that means they sold 23,652,000 phones in 2011 with a standard deviation of 10. And they looked at the pphone sales data and determined that they are normally distributed. Sample of size 4 are taken from the normal distributed 2011 sales data. What is the shape of the distribution?
Where are we?
Normal.
We're on.
We are in the part 2 on the preparation.
For what lesson?
Lesson 7.
Okay, yeah. Okay. I had pulled up number 6 and I was like, this all looks very familiar. Okay. Alright, I'm on it.
Okay, so I know the answer is normal, but isn't the number low?
Well, that's because it's normal if it's the parent population normal or the sample size is large. Either or, it makes it normal.
What was it again? Say that again. I'm sorry.
It's normal for 2 reasons. I mean, under 2 conditions, it's always normal, and it's if the parent population is normal or the sample size is larger than 30 or larger.
So since it's larger than 30, I mean, since it's normally distributed.
No, it's less. It's only 4.
Yeah.
But it's the parent population is normally distributed.
Yeah.
Yeah. So if the parent population had been right skewed, then the sample distribution would be right skewed as well. But since it's normal,
It's normal.
Okay, it's normal because it's normal. Okay, so because it's a very large number, that's why it's normal, right?
Well, in this case, it's because it's already normally distributed.
Okay.
It's because the parent population. Do you know what the parent population means? The word?
Yeah.
The population you're pulling from. And it says in the information that it's normally distributed. That's why.
Okay.
It's normal. So it'll always be normal if the population is normal.
Yeah.
Okay.
Number 5. Sample of sales 40 are taken from the normally distributed 2011 sales data. What is the shape of the distribution? It's
normal
in this
again,
one.
right?
It's still normal because the parent population is normal, and if the parent population had been like right skewed, it would still be normal because it's over 30. Yeah, and number 6, a sample size of 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed X is greater than 40? Oh, X is less than 40? Yeah, less than 40. So did you guys do that one?
I didn't.
Yeah.
Okay.
Well, so it's the same as when we would just find the probability that it was less than 40. The only thing we changed was we first. So I took 10 divided by the square root of 4, and that's 5. And I plugged in the 5 into the equation instead of the standard deviation.
Okay.
Yeah, so it was 40 minus 45 over 5, and that equals -1. And I think I plugged that into the normal probability applet.
And got the outcome.
Yeah, which is 0.1587.
Okay.
Does that make sense?
Yeah, and that was
I'm
Yeah,
glad you
little-
did it. Thanks.
yeah, that makes sense
Sorry.
more that
Like this lesson's pretty much reviewed. It's just adding one step.
into it.
Yeah. So it's the stuff we did 2 lessons ago, but one step added. So number 7, a sample size
Step
of
added was just the probability output, right?
the stuff added was the
Just
standard
typing it into
deviation.
the probability output.
Finding out the standard deviation
Yeah.
Okay.
because we didn't know
Okay,
before.
that's easy.
Yeah, just taking the sample size, the square root of the sample size, and so like the standard deviation over the square root of the sample size, and that's the new standard deviation.
Yeah.
Okay. So
That makes way more sense.
number 7, a sample size of 4 is taken from a normally distributed 2011 sales data. What is the probability that the observed value is greater than 35 and less than 55? So what I did is I took 35 minus 45, because the mean is 45 and yeah. Then I put it over 5, which was our new standard deviation, and I got negative 2.
Okay, that's what I got.
And I found the z-scores for both of those things, the 35 and the 45, and they're both
You
within.
mean 55?
Yeah.
35 and 55, or you said okay.
Yeah, they're both within
You
2.
said 45, so I wasn't sure I was looking at the right one.
I'm on the call right now. Sorry, the tutor that I have. Yeah, I'm on the. Oh, yeah, you're good. I scheduled tutoring for the time that we have this call, and so I just texted him, and I was like, sorry, I can't make it. I actually have a stats call, and he just walked by, and I'm like, I'm on the call. I'm like, I'm right here. I'm like, hello, awkward, hi. Okay, sorry, what question were we on? Let's see.
Number 7 still.
Okay, cool.
So both of those numbers, both of the z-scores are actually not the. I don't think. Did we even need to find the z-score?
I don't think so, but maybe I did it wrong.
Yeah, I think I just did that anyway.
I was like,
Just for kicks and giggles, I guess. But 35 and 55 are both within 2 standard deviations of the mean. So that the rule, the 68, 95, 97 point,
it'd be
whatever. Yeah. That since it's 2 standard deviations, it's 95.
Okay, cool.
As the probability.
That's what I got.
It's a lot simpler than I just made it sound.
I know, I was like z-score, and I was like, oh wait, dang it, I did it wrong.
You know what? That's what I find. You know, I read all these things, and it's like I don't need to read it. I think I can figure it out without reading it. But then, kind of, when you read it, it sounds complicated, but it's not.
Yeah.
Right?
Weird. And the number 8 is in the same format, pretty much. And it's the same answer.
Yeah, I was gonna say, I was like, I got 95 too, or the 95%.
Yeah. So those numbers are both within 2 standard deviations of the mean.
Mm-hmm.
Okay. Number 9.
Yeah. A sample size of 25 is taken from the normal distributed 2011 sales data. What is the probability that the observed data is greater than 50? Let's see. I don't really understand my notes on this.
Let's see. I'm looking back at my notes.
So
I don't think I got this one right, so I'm not sure. I think I looked back at the answer sheet and it was wrong. So I'm not sure what I did. But
And this was not explained in the video, right?
Actually, it was, because I remember this part, when you just find probability,
Was
but I
it?
don't remember how they did it. I remember because I did it right after, and I got the answer, and I got it right, but now I don't remember because it's been
Okay,
so long
Oh,
since I
you
did
got
it.
it right?
It was, I got I got it right. It was 0.00621 is the probability that it would. And I think, but I'm not 100% sure, you took 50 minus, or you took the, was that the one where you took the, oh, see, I shouldn't say anything because I'm going to mess you up. Because
Okay,
I
wait.
can't remember how I did it. I'm trying to think how I did it.
Well,
But don't
what
you take the observed minus the mean, and then
Yeah.
also, like, it's one more step. It's that one more step. Because you're looking for the probability.
So what I have written down is like the answer is 2.5. And maybe I
Oh, I didn't
plugged
get
in the
that.
probability applet after that. Do you remember using the probability applet?
Okay, so this is for
I
number
do,
9,
but I
right?
don't remember how I did it.
Yeah, this is number 9.
Okay,
Yeah, greater than 50.
I'm gonna pull up the answer key.
I have the answer in front of me, and mine matched, and it was 0.00621.
Oh, okay.
I just don't remember how
Yeah,
I got
that's
it.
what it is. So you got that right?
Maybe
I got it right, but I did it last weekend.
That's the
And
worry.
so, and I didn't have any time to like review right before because of my flat tire and all the things going on. But so I watched the video and I did it right after, and I remember it was in there.
Okay.
But it was towards the beginning because it talks about finding the probability.
So what are the chances of this being on the quiz? Just kidding. That'll probably be like
I don't
4
know
questions
because I
about
kept
this.
doing it again.
Oh, I think I figured it
Yeah.
out. You do use the normal
Oh,
probability.
you remember it?
Yeah. So when you do that one more step and you divide it all through, you get 2.5. And then you plug that in as a z-score, and you just highlight what's above 2.5, and that's 0.0.
Okay. Because you want to know what is greater than 50. Okay, yep, that
Yeah.
makes total sense.
Yeah.
So the extra step is just the taking the, no, you don't do the extra step this one, do you? Because what would you subtract?
Yeah.
The sample size, I think.
So you do 50 minus, did you do 50 minus,
I did 50 minus 45
Or did you-
over 2.
you did 50 minus 45
Yeah.
over 2.
Uh-huh.
Oh, because the mean, the mean. Okay, so the extra step was the 50 minus 45. I get it now. Okay. It's coming back.
Yeah, I guess I'm kind of having a trouble finding a balance between getting things done and leaving myself enough time and then doing it close enough to the meeting where I remember it.
Yeah.
I know. That's the Wednesday one. Because if you do it, I keep adjusting my schedule because I do it way ahead, and then today I can't remember anything.
Exactly.
Yeah.
How did I do that again?
So I got to be able to review right before.
Yeah.
Yeah,
This time I just wrote things
I have to
down.
change my technique as well.
It helped a little
Oh,
writing.
you took notes when you did it?
Yeah, like I wrote down the steps I did.
And the hard time is because we have our meeting on Tuesday that it's hard to get enough time to do it all.
Yep, that's why I try
by
to
Wednesday,
do it ahead.
You know, the weekend of before, that's so good. It's not working so good.
Because we don't have anything to do at the end of the week.
Okay.
Yeah, maybe doing the hour before we. It's crazy schedule.
We'll figure it out.
Yeah, just some review.
We go.
Yeah. So number 10.
Yeah, that one, probability. I remember finding probability is that extra step. Did you do that on 8 and 7 as well? Did you subtract? Because it
eight
says
and
loading?
seven.
Yeah.
I just did this. I found out the standard deviation. So for A,
But
it was
you didn't take the probability of that x is greater than 41. You didn't do anything like that?
no. I
And
just
less
found how
than
many.
49. Oh, I guess you couldn't. There's nothing to subtract because it's too broad, huh?
Yeah, you just find how many standard
Okay.
deviations it is, and then apply the rule.
Okay. And you're using it by the 6895 rule, and that's how you do it. Okay.
Yeah.
All right.
All right, number
Bring me
10.
back. Thanks.
Yeah, number 10.
Number 10, samples of 4 taken from the right skewed 2010 P-phone sales data. What is the shape of distribution of X? Right skewed because the sample size is 4 and that's smaller than 30.
Yeah,
Mm-hmm.
that's what I got.
Yeah. And then number 11, sample size of 40 are taken from the right skewed 2010 P-phone sales data. What is the shape of the normal distribution of the means?
I have basically normal because it's over 30.
Yep.
The
Yeah,
sample
they
size
say
is large enough.
approximately normal on the.
Oh,
They say
yeah.
approximately normal on the.
I guess that sounds a little bit better than
yeah,
basically
something.
normal.
Yeah.
I think it means the same thing. I think it's
Basically
okay.
normal.
And
Okay.
sorry, what?
No, that's good. I was going, number 12 next.
Oh, okay. Is there a theorem that justifies your answer for 11? What is the name of the theorem?
Central limits theorem.
Yeah. How I remember the theorems is like, so the large numbers, those are all made of like lines, but the L and N, but central limit theorem, CLT, like the C is kind of like a circle shape, so that has to do, the CLT has to do with shape. That's how I remember it.
Oh, that's good. That's awesome.
Oh, that's a good one. See a circle. That's right. Cool.
And 13, a sample size of 4 is taken from the right skewed 2010 P-phone sales data. You want to know the probability that the observed mean of the means is less than 35. Can you compute this probability using the normal probability applet with the information you have? Why? And I said no because it's only for normal distribution.
Yeah.
Yeah, and this is not normal.
Yeah, it's right skewed.
Mhm.
And
Okay.
14, a sample size of 36 is taken from the right skewed data. What is the probability that X is greater than 36.5? And for some reason, I don't have that one. I don't think.
Okay.
Yeah, I think I just skipped that one for some reason.
I wrote down 0.9599, but again,
That's what I have.
don't know how I got that.
Yeah.
And it's right
Right.
because I double checked them all. Like it's the right answer, but.
I think that one was
Good,
the same deal, like with the normal probability.
36 minus the 35 over, right?
Yeah.
Over square root of 4.
Uh-huh.
Yes. And then
Okay.
plugged into the normal probability applet, and that's how you got your answer. And number 15, a sample size of 36 is taken from the right skewed data. What is the probability that the observed value is between 37.5 and 42.5? And for this one, for some reason, I just have -1 over 0.282847271 in like in my notes, but I have the answer 0.9599.
What
Okay,
was that the formula
14.
you were trying
That
to
was
use?
14, right?
15.
That's number 14. That your answer was for number 14.
Oh, 9.5.
7
9.
point.
Yeah.
.9599 is the answer for 14.
Oh, I wonder what happened.
Yeah. So 15, I actually kind of remember that one. It was the step one. This is what I did. The first step I did was to see if it was I just typed it in the probability applet to find out if it could be less than 37.5 by just using the applet, and got .1056. And then I did the same thing. I did mean greater than 42.5, and I got same answer, .1056. And then I just subtracted them. One from, I took one and just minused it. And I know there's two ways to do it, they said, but they always said the easier way was from whole. Remember?
Yeah.
Do you remember? It was like 2 chapters ago. They said take one minus
whatever.
And then
it
you
is.
know, yeah.
Yeah.
It was like when we were doing those little fractions, like the dice roll or something. And this is just for one to find out. So I minus both of them from one because it says and, not or.
Yep.
So I minused both of them and got
The same.
0.7888.
Okay.
Yeah, I didn't even do 15.
Does that make sense?
Yeah, but that makes sense when you just explain.
Did you understand?
Yeah, when you were explaining it, it made so much more sense.
Yeah, now that you say it, yeah, it's easier.
I guess that's why we did the group work, is because I think when we discuss as a group, things make sense that didn't before.
Exactly.
Yeah, you just kind of want to throw your hands up and say, oh, I can't do this.
Yeah, I'm like, oh, wow, like, why didn't I think of that before? Like, that's exactly how you do it.
Well, I couldn't think of another way to do it, and I just remembered a couple chapters ago they had the one, you can find out what the probability is because it always equals a whole.
Mm-hmm.
Yeah.
Okay. So, awesome. Should we go to take the quiz?
I guess.
Sure.
All right, let me see if I can get to it.
Mine is really slow. I'm going to turn my count is being really slow, and I'm not sure why. You guys don't mind because none of yours are on, right?
Yeah, mine's not on. Because usually I'm not looking at it because
I'm hoping it'll speed it up if I do that because everything's loading really slow.
Yeah, I'm just trying to find. Okay, I think I got it. Should we start it?
Sure.
Yeah.
It's really hard to find things on my cell phone now.
Oh, I bet that's really.
Yeah, I'm like trying to find it, and I'm like, where do I go? Okay, so I have to like zoom in.
That would be hard.
All right. Okay.
Yeah, it's gonna be hard for you to find the applet then.
I just barely saw that as as question number 3, and it's like normal probability applet. I'm like, oh, okay.
Yeah, we'll do that.
You should just let us do that. Let us do the normal probability applet.
Okay, that'd be cool. That'd be great.
Yeah, we'll do it.
Try that.
It'll be hard.
I know. I just saw that, and I was like, oh goodness. Okay. Let's see. Is everybody on?
Yeah.
Yeah.
Use the normal probability applet to find the combined area under standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358.
Oh, okay. So we just
Okay,
need to plug it
Genevieve, I
in.
trust you. You like know what you're doing, Genevieve. You seem to remember everything the best this week.
I
You're
know.
carrying us.
I don't know. This is weird. I don't really understand math normally. um,
Because
Well,
we
I'm
we
glad
have a
to
group
hear.
for this semester to help us out.
yeah, I think this is farther than I ever got before.
Good.
But for
Use a normal probability output. to
for this
find the
one, I
combined.
think you put in the z-score 1.358, and then click the area in the middle, and then the area is your answer. I think because to the right of the
Because
positive.
it's right. Wait, it says to the left of the negative. And it
Oh,
says to the right of the positive. So I think we want the outliners,
okay.
right?
Yeah,
Isn't that what it says?
to the left of. Okay.
You know what
Yeah,
I
it
noticed
does
with
say-
the I noticed that we can't copy and paste. You know, like instead of copying the number right here, put in the
Mhm.
applet, we can't do that.
Oh, really?
Yes, we can't. Yeah, at all.
That's annoying.
It is.
Okay,
Okay,
so I got to the left, and I did the left and the right, not the center.
Okay.
So it's to the left of the negative and to the right of the positive, it said. And I got 0.1745, which would be rounded to 0.175. Did you guys get that?
Yep. I don't know
I
what
got
this question.
I got 1.745. That's what you got, Marianne?
0.1745
Yeah. Okay.
So it'd be rounded up to.
to
Point-
0.175, yeah.
I guess they're trying to see if we knew our left from their right. From our right.
I know, it sounds kind of too simple, and you're like, is this a trick question? Because that's
I'm like trying to visualize this as you guys are doing it. I'm like, okay, which would I click? And I'm like, well, okay. Like, all
it
right.
sounds a little bit easy. But
I
okay.
failed that test. That little quiz. Which of the following population will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations, x, the distribution of the sample means, r, this cannot be determined from the information given.
Smaller standard deviation if 9 hours around from population. Okay, so it's small, so you can't
Yeah.
say that it gets smaller because it's small.
Yeah. Because we know that it's a small sample.
So the sample means would
The
be,
last one?
right? The sample means would be smaller. Because
The distribution of the sample means, though?
yeah, it would be smaller than the standard deviation. Which of the following will have a smaller standard deviation if 9? Oh, I guess no, because it's considering the 9. So.
Yeah.
Okay, let me
This
ask a
cannot be
quick question.
determined?
What's the difference between the X with the little thing on top and without it?
So the one with the
So-
line on top is the mean of the sample. Is that correct?
Yeah,
The
it's the samples all together. It's
Yeah.
like, you remember when we went on the beginning of the chapter and we had to push that thing and it gave you a bunch of samples? And then we were
Yeah.
averaging their mean? That's what it is.
Okay.
And
All
it's
right.
called the X bar. When they did it on the tutoring thing, when you watch the video, it's called the X bar.
Okay.
So what they're saying is the distribution of the mean or the distribution of the, so which one would be a smaller standard deviation? So that would be,
I don't know. I can't like. Because one has the X bar, the other doesn't. So one's about the whole one individual, the other
the
is
whole
about-
group, yeah. One's
Yeah,
about
the whole
group.
group.
What was the large number theory? Maybe that will answer it.
I need to go grab my notes. The large number theory was, well, but we don't have a large number. We only have 9
Yeah, we
ounces
don't have it. The large number theory is that if the sample size is greater than 30, then the
That's the shape
X
one.
bar would roughly be the same as the mean. Of the,
I'm gonna go grab my notes. Hold on.
It would be the same as. Okay, so.
Okay, sorry, I'm back. Did you decide something?
No.
no, I was looking at my notes.
Okay. Yeah, Wednesdays are always harder. I've decided.
Yep, the second one. I agree.
Distribution of the sample mean.
Okay, so the mean will be normal if so it's size increases so it sound like it's smaller and more accurate, but we have a small size. Did you come up with a decision for 4?
No, I'm still.
Okay.
I mean, I want to just put this cannot be determined, just because I don't
Yeah,
know.
That's kind of what I'm leaning towards too.
Okay, cool.
that was my first thing. No, because
Hmm.
Because either the parent population has to be normal, and it doesn't
Yeah.
say, or the sample size has to be larger than 30.
Which neither of those are true.
Yeah.
correct.
All right.
So
Well, we
probably.
can find out if we're wrong.
Yeah, that's true.
All right.
So do we put it? This cannot be determined.
Yeah,
Yeah.
that's what I put.
All right.
Which of the following results implies that the spread in X bar decreases as the sample size increases? Was that the law of large numbers?
Yeah. Okay, wait. This. Sorry, I just had to
Spread of
like
distribution of the X bar
decreases.
decreases with the law of large numbers. And the
Yeah,
other one is
so-
shape. Like the
Yeah.
CLT is shape.
Yep.
Yeah.
So I would
Well,
say
does
it's
this
large
one-
numbers.
Yeah.
Does this one kind of answer for it? Because it says the spread decreases as the sample size increases.
That's
we have a
right.
yeah, but we have a small sample size. They're saying we have 9.
Yeah. So the distribution of individual observations.
Would be bigger.
So
That's hard to say.
Yeah,
So
I
like,
would say if it's cannot be determined, it would be the distribution of individual observations without the X
Yeah.
bar of the mean.
yeah, we
Like
can
that'll be
try
our
that.
second try.
Yeah. Okay. Yeah. This is that one. That's just.
Do you
really
want to try that one first, Genevieve? Because we trust you. If you have a
I don't
strong
know.
opinion, we'll go for it.
yeah.
Me might be a
You
mistake.
want to do it? It's okay.
Well, if it is, then we'll just do the
So-
other one. It's totally
Yeah.
fine. All right.
You
So
wanna
for
try
number
Sure.
4, we're gonna do. What are we gonna do? A.
Yeah, the distribution of the individual observations with the regular X, not the X.
Okay. Cool.
So those would be smaller.
Okay, so for number 4, we're doing the second one, right?
The first one.
The first one.
The first one.
Yeah.
Okay.
We're going to let Genevieve take her guess.
Yeah, and if we're wrong, it's fine. We'll just do it to our other one. Totally.
I
Fine.
was thinking the second one.
Oh, you're
Oh,
thinking
you were
the second
thinking
one?
the second one because the sample's too not large, right?
Yeah, the sample's not large. I have no idea what I'm thinking, honestly.
Yeah, I don't think the second one can be true because the sample's not large.
Yeah. So it's
So
the
it's
first
either
one.
1 or 3.
Okay.
Well, my
think.
first
Well,
answer was number 3 because I don't know, but
Do you want to go back to number 3, guys?
I hate how it's worded. I just
I
can't.
know.
Let's go back to number
I know.
3. Okay, we'll go back to
Also
number
right.
3 because
so number 3 for number
4.
4, right?
Yeah,
Yeah.
the
Okay.
last one.
Yeah. It's so confusing. We're
Okay,
like,
so
three,
number
four.
5,
Number 5
so for
is
number 5,
the last one.
the last
Yeah.
number, yeah.
All right, now number 6.
Scores on a quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. Diane earned a score on the quantitative portion of the GRE of 160. What is the z-score corresponding to Diane's score?
So we take
So
Okay, so
160 minus 150.8
uh-huh.
over 8.8.
Yep. Are you? I'm getting my calculator.
So we don't do the square root of or anything like that on this one, huh?
I don't think so.
No.
But
Okay.
If it was more than one person, then we would.
Or we were
it's just
if
Diane.
we were looking for probability, right?
If
No.
we were looking for the mean of the mean, like the new standard.
Oh, okay. Okay.
all right.
Sorry, go ahead.
I don't know if this is right, but I just got. Hold up. I think. Okay, so I got 1.0454. I think I switched that though. Is that what you got?
I must have done something wrong because I got a negative.
Yeah, that's what I got.
You got 1 point, or you got a negative?
I got
a
1
negative,
point.
So let me do it again.
Could you do the
I don't know what I
160 minus the 150.8?
150.
Yeah.
I must have hit something wrong on my calculator because when you think about it, it shouldn't be right.
Okay,
there we
so
go. That's better.
So it's 160
Yeah,
minus
1.045.
Yeah, so we're
Yep.
just looking for the z-score, so I guess that's our answer.
yeah,
Rounded to 3 decimal places.
so it'd be 1.045, right?
Yeah, 1.045. Yeah.
Okay. What is the? Okay, then the next one is we're trying to find the probability.
So that's where we do the anything we learn.
Square root. Oh no, that's the standard deviation.
This one is a randomly selected student will score above 160.
So do we find the z-score and then we have our z-score.
Okay.
So do we type our z-score in? Yeah, we would, huh?
So yeah, this is what we applet, right?
I don't think we have the z-score we're supposed to type in yet because we're supposed to find a randomly selected student would score above 160. I don't remember how to find that.
I think what we have the z-score because we just figured out the z-score for 160. So we shade in the 2,
which would be
type
yeah.
in the
yeah.
Yeah.
For some reason I thought 116.
So we put it in, which is 1.045.
0.45.
Yeah.
And then we shade in
and then anything above, right?
Yeah.
So I got 0.148.
Yeah, 0.148.
Did you get the same one? Okay.
Yep.
Yeah, 1.48. Yeah.
Wait, so
0.148, yeah.
0.148. All right, because I don't have the applet.
Yeah.
So.
Yeah, you gotta just rely on us. Good luck with that.
I'm like,
you're a
okay,
trusted
it's
girl.
1.148. So you got that right? It's 0.148.
Okay.
Right?
Yeah, 0.148.
Uh-huh.
Awesome.
Okay. And then the next one, this is where we apply that new thing. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these student scores?
Do we find out the sample mean by adding them together and dividing it?
Yeah.
Okay.
So we get the mean, right?
Yeah.
We add and divide.
Plus All right, I got 160.
Me too.
Yeah.
Yep.
I did 160.
Same.
Yeah.
So what is the z-score corresponding to the sample mean of these students' scores?
So then we just find the z-score,
Oh.
which should be.
Yeah.
Well, we're
Wouldn't
at
it-
160 again. So
yeah,
it's the
so
same
wouldn't it be the
thing.
same?
No, because we do the little thing with it this time.
Oh.
Yeah, we do.
So we do we do 160 minus again, or do we just do 160 over?
160 minus 150.8 over 8.8 to 8.8 divided by the square root of 5.
Oh
8.8.
yes. Okay. So we take 160 minus 150.
Did you get it, Genevieve?
Yeah, so it's
What'd you get?
3.93547.
Okay, I got something different. Let me recalculate again.
So what
So
do you, what you got, Jennifer?
I got
3.1.
3.1. Let me do it again. So we
I
had
got-
160.
And
What did you
Oh
get?
no,
Jenny-
I was doing the standard deviation of the means, that thing.
so what did you get, Genevieve, though?
3.9354 7964.
Okay.
That's not it.
I
Is
don't
that
know what
you
I'm
got,
doing.
Steph?
Nope, that was not.
So
Okay,
that
I
I
didn't
don't-
get that. I got 3.1. So should we do it again? So
Yeah,
it's
so what-
160
Okay, yeah, let me
minus 150.8
Okay.
divided by 8.8. The square root of 8.8, right?
No,
No,
just
8.8.
8.8.
Yeah.
8.8 over the square root of 5.
That's what I did wrong. Okay, I didn't do that.
But the answer I got was just 8.8 over the square root of 5. I hadn't done the 160 thing.
Oh, okay. All right, I gotta get it.
So what did y'all get
Make sure we-
after you do that?
Divided by 3.
Okay. I am very insecure about this.
I got 2.33770743.
I
So
guess
the
it's gonna
z-score is 2.338. I don't know if I did that right.
Oh. Well, that wasn't what I got, but I think I'm doing it wrong. So okay, let me just tell you what, like, I typed it in. So 160 minus 150.8, right? Divided by
Yes.
divided by 8.8. And
No.
then
divided
oh,
by
that's wrong?
8 over. Well, I don't know if you can do
Divided
it.
by
over.
what?
I don't know how
I
possible
did
it
that.
is.
I did what you did, Steph.
Because I
And I
did
got-
I put because I went divided by 8.8 and then I put divided by the square root of 5.
Yeah.
Well, what I always do is I do the standard deviation over the square root of the sample size first. So it's just a problem of division instead of.
Okay.
Oh. Okay. That makes sense.
I like that a lot better than mine.
Yeah,
an
it's
order
less chance of a mistake, huh?
Yeah. Okay, so what did you get,
Okay.
Genevieve?
I got 2.338.
Okay. What is the z-score correspondence?
Yeah, that was the z-score I got.
Okay, and then that's the answer, right? Because that's what we're looking for. We're looking for the z-score
Yeah,
corresponding to sample mean.
Yeah,
It
2.338.
makes sense. That's easier when you do the bottom first.
Uh-huh.
Because otherwise, I don't know how to separate that on the calculator.
Yeah, exactly.
It gets really complicated.
Okay, cool. I think that
Okay.
sounds good.
All right. Thanks.
Yep. And then number 9, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
So we type in the Z-score on the thing, I guess.
Which
Oh,
was 2.338.
Yeah, and then
338,
shade what's above.
And then the question is
Is that with the
mean score-
probability output?
Yeah.
Yeah, and
That's
I
with the
got
outlet?
.0097. Is
Yeah.
that what you got, Genevieve?
Yep.
What you got?
And we're doing to the.
I got .0097.
Okay.
Which, wait, if we round, are we supposed to round? No, it says.
Here, let me try my .0097, right? Is that what you got?
Yeah.
Okay, got it.
And then, oh wait. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that the distribution is left skewed. A random sample of 81 students will be drawn. What is the shape of the sampling distribution of the random variable which represents the sample mean of the 81 students who are selected?
Approximately normal. Yeah.
Yeah.
Because
What question is
again?
Number
this
10.
is number 10.
Oh, okay.
It's approximately normal because the parent population is. Oh no, not because no because
It's because the sample size is
the
so
sample
big.
size is large. Yeah.
Yeah.
So what is it? It's
Approximately normal.
okay.
So, what is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population?
What's the mean? Okay, wait. What is the mean of the distribution of the sample means? Sampling distribution for all sample sizes. I don't even really know what it's asking.
Me neither.
Okay.
All right, let's see.
Okay, let's say it again. What is the mean of the distribution?
This is sampling distribution.
So the sample size is 81, and we just figure out with the square root of 81, right?
I think so. Is it is that how we find the sample mean?
Yeah, I think so. Remember they had that equation. I can pull it up again.
Yeah, well, yeah, if you want to look that up, that'd be awesome.
But we were doing it. It was the x minus, wasn't that the equation or no? Let's see.
I don't think so. Let me check. Hold on.
The square root of 81, do we need to find that?
Yeah.
It's
Square root
9.
of 81 is 9, yeah.
Yeah, it is 9.
So
Then what do we do?
is it 0.7 over 9? And then let me see if this makes sense.
Well,
So the standard deviation of the means is 0.077778.
77777.
Yeah. So I mean, I don't know if this is correct, but do we take 3.5 over that? Those are the only numbers we have.
What else do we do with
I'm
it,
like
right?
confused because I was looking at something else. I was looking at the equation, and that's not it because that's for the z-score only.
Yeah.
So what I had in my head was totally off.
Oh,
So I wasn't listening to you. But
same thing. The mean is 3.5 because the mean of the sample means and the mean of the parent population are the same.
oh, Yeah, duh. Thank you.
Okay, Genevieve, say that again.
It's the same. You don't
3.5.
need to do anything. Yeah, it's 3.5 because it's
Yeah.
the
Oh
same.
my gosh.
Okay, Genevieve,
You're
I
making
didn't
this
miss
way too
that. What did you
hard.
say? I'm sorry. I
So
missed that.
the means of the sample means and the parent means are the
Ah.
same. The only thing that changes is the standard deviation. So the answer is 3.5.
3.5, which is this. Oh, tricky
gosh.
math, people.
And we were looking for the before. And
Yeah.
then the next one is what is the standard deviation of the sample mean?
Okay, and that's what we need to.
Yeah,
That's
so
the 81 divided by.
Yeah, that's where we
So
have
that's
to.
9, right?
that's the 0.07777 thing. So it's four
Okay.
decimals.
0.
So 0.7778.
Point. Go ahead. Say it again.
Sorry, can you say that again?
0.7778.
8.
Cutting off. It's 3 sevenths, right?
Yeah, 3 sevens and then an 8.
8.
Yeah.
And that's for
So
number
it's
12.
for number 12, it's 0.07778.
Oh, I thought it was 0.778. There's not another 0, right? Which is
No, just 3
0.7778.
sevens and an 8.
Yep.
Yeah, because it's 4.
Oh, okay. So we don't put the 0 before, so it's
I mean, you
0.0778.
can.
You can. It'll still count it right.
It doesn't make
0.
any difference.
So it's 0.778. I mean,
7778.
0.778.
3 sevens.
Yeah.
But an 8.
So this is what I have. I have 0.07778.
No,
Yeah.
not point 0.
Oh, yeah.
0
Oh, God.
point.
Yes.
0 point. Okay.
Yeah.
7778.
Yeah.
Okay.
And then,
Y'all got that?
yeah.
Oh,
What is the
3 more
probability?
questions.
What is the probability that the
How many?
for 81 randomly selected BYU Idaho students will be less than 3.3? So I guess for this one we're doing 3.3 minus 3.5 over what we just got. So 0. Oh, the last one, actually the answer wasn't 0.778. It was
Okay, it was just the one I thought it was, huh? It was just
Yeah,
the
it was
square root,
point-
which is 9, right?
no, because the standard deviation before was 0.7. So it's 0.7 over the square root of 81, which is 9. So 0.7 over 9, and that's 0.0778. I read that wrong.
Okay, now I'm confused, so sorry. I
So
follow
she
you.
was right.
So what's the answer to 12?
0.0778. Sorry, I read that wrong.
It is 0.07. Okay.
0.0778.
So number 12 is 0.0778. 27.
0.077.
8.
Yeah.
8.
Yeah. Usually when I get things wrong, it ends up being because
Trivial.
I transferred the number wrong, and I can't read numbers for some reason.
Yep. Same.
Okay. So the next one.
So I'm sorry. What's cutting off? So it's 0.0778, right?
Yes.
Perfect. Okay.
Okay. All right, I'm ready.
So the next one is 3.3 minus 3.5 over 0.0778. That's the z-score, and we put it in the probability applet.
Okay.
the answer to that is negative 2.571.
In the z-score, right?
Yeah.
That's the answer.
2.571. That's the z-score.
Yeah, and then we put that in the
And I got,
Is it negative?
But you just put
We're
it in the
looking-
applet.
Yeah,
Yeah.
we're looking for less than. So
Okay,
we
so
should
it's
2 or 1.
well, less than, you said the answer was negative, so we can only do the little coloring on the left, right? And mine won't
Okay.
click off the first one.
okay. So it's
Mine-
let's see, negative 2.571, right?
Yes.
I
Got it.
can't click my color off on that one. It won't, for some reason, won't click off.
What I ended up getting was 0.0051, and yeah, so answer is
Okay. 0. Say it again.
0051.
Sorry, can you say that one more time?
Yeah, it's cutting off.
No.
This is 13, right? Let me see.
Yeah.
No, we're on
0.
14.
We're on 14?
No, we're on 13.
Yeah, we're still on
Oh.
13.
Yeah, 13.
Oh, yeah, you're right. Sorry. That's everybody
So
else.
the answer
Okay,
is
so-
0.0051.
Okay.
Okay.
And then for the next one, we just have to make it greater than 3.3.
So same thing.
Yeah, except we shade the 2 to the right. Is that right?
Yeah, we do
Yeah.
it to the right, I think.
Okay, so 0.9949. Oh, but
Okay,
3 decimal
0.9.
places. So 0.
I got the same.
Yeah.
0.9949.
But they only want 3 decimal
Oh.
places, so 0.995.
Okay.
And then just one more. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weight is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed this sample.
Do we use the probability applet?
I'm not sure yet.
Or am I way off?
This is a long question.
Yeah, I think it's similar to the last question on the preparation.
Yeah.
Okay, so then we do what I did and we figure out each one.
Yeah.
I think so. Yeah, let me see. Yeah, I think so.
So we want to figure out the probability that a random sample of passengers will have a weight that is above or below the mean.
That is as extreme or more extreme.
Yeah.
So don't we just find the z-score and then type in each side? Oh, we can't with that, huh? Because you don't have the. Never mind.
Macy's Coast Guard.
I have no idea.
Yeah, I don't even like. I don't.
Like totally blank.
All of us are just silent. We're all just like thinking like
I'm not
I
even
don't.
gonna say anything. I'm not saying anything this time.
Like I have nothing.
I have nothing to offer. Okay, so the sample size is 48. Let's just write out like what we know.
Well, yeah, the information we know.
Yeah, so that we
Yeah.
can like look at it less as a word problem and more as something to look at. So the sample size is 48.
And the standard
N equals
deviation
48.
is 26.
Yeah, the standard deviation is
26.7.
Yeah.
Okay.
So if we were trying to find a z-score, first we'd find
hold
the
on,
standard deviation.
26.7. We got our sample size is 48, 26.7. Our mean was 177.6.
Okay.
Is our mean.
Our normal mean, I think our mean was 185 and the sample mean was 177.6.
Oh, the sample mean, yep. So our normal mean is, no. Oh yeah, our normal mean is 185. Okay. So the sample mean is 177.6 and the normal mean is 185. Okay. So if we want to find out what the possibility is above or below, right?
Yeah.
Yeah.
And we find the probability. Okay, so then we do the 185 minus 177.6, right?
Uh-huh.
And I think it's just a normal equation, a normal probability equation. We do 185 minus 177.6 over
3.85.
26.7 divided by the square root of 48, right?
Okay.
Yeah. I just did that, the square root thing, for the standard deviation. And it's 3.85381,305. So
So that's not our answer, is it?
no.
No, that's just the square root.
Yeah, that's just this. Yeah, that's what I was.
Sorry, ladies, I'm so lost in this question.
You,
Yeah, I might
you know
try
what?
to
Once
think.
we took the numbers out and wrote them down, it makes a little more sense, hopefully.
Okay.
Oh, I think it's like the first question, where we're just doing the left and the right. So the z-score
Yeah.
is 1.92017, and I think we put the z-score in the
Yeah.
normal probability applet, and then do the left and the right.
I think you're right.
And that is
I have no help on
0.0549,
Oh,
if we're right.
wait, for above?
For above and below. So remember the first problem where we did the left and the right,
Mm-hmm.
but left the middle blank? Yeah.
I got a different one than you. I got 0.0274. What did you type in for the z-score? 1.92017?
Yeah.
Oh,
And that
I
rounded.
forgot to include the left. Okay, 0.0549. So do we subtract 0.0549 from 1 like I did?
Maybe. We're looking for what the probability is that it's either above or below what they think.
So I think it is 0.0549, huh?
Yeah.
Yeah.
And we have to round again to 3 numbers.
4. Oh, yeah,
So we
3.
do, so 0.055.
Yeah.
Okay.
Was 0.055?
Yeah.
Oh my gosh.
Okay. So I'm going to submit mine, and if I get it all wrong, I'm going to tell you which ones, and I'm going to have to redo it another time because it's already 11:30.
Yeah.
Okay, so what's number, again, what's number 9? The answer for number 9?
For number 9, I got 0.0097.
Oh, okay. 0.9.
Okay, what did you get for number 12? Tell me again 12.
Okay, sorry. Tell me again number 9 before, sorry. 0.
I'm sorry.
Number 9 is 0.0097.
Yeah.
Oh, okay. Oh, okay.
And
Thanks.
12. Get for 12.
Number 12 is 0.0778.
Okay, that says round to 3 decimals, so we should have
Oh,
78, right?
yeah. 0.078.
Okay.
And for number, this is 0.0778. That's for 12, right?
Yeah.
Yeah, but
And
we
number
rounded to 3
13
decimal
is-
places.
Yeah. And number 13 is, did you get 0.005?
Yeah, did we round to 3 decimal places? So
Yeah, it says 3
0.005.
again. Okay.
Oh, so
and
no
number
one?
14? And number 14 is at 0.995?
Yes.
Okay. And then number 15.055. Okay. I'm going to do it, guys. Let's take the bullet.
Okay.
Alright.
Ooh, good so far. Oh, no. This cannot be determined from the information was not the correct answer.
Which one?
This cannot be determined.
So
Which
should
of
we
the
do?
following? What's number 4? Try another one.
Alright.
So do we
Take
Which
a
one was
random
one?
guess. Because you have 2 tries, so that
The-
if you guys take
the
a
middle?
random guess and someone submits it, then we'll know.
Okay. So what's the other ones that are wrong?
That's it. That's the only one we
Oh
got
my
wrong. Can you
goodness.
believe it?
Wow.
I really thought we'd get a lot wrong.
I really thought-
I really thought we'd got a lot wrong. I thought we were just gonna blow it and have to like
Me
take some time and
too.
go over it.
Me too.
So it's just the one.
Okay, and my phone is not letting me submit, but luckily I saved all the answers, so.
Okay.
Yeah.
So
Okay,
if someone
so
wants
number
to
4,
submit another
the
try,
middle one.
okay, somebody
Okay, number
submit the
4, I
middle
just
one and then
said
submit and see if it's right.
Yeah,
Yeah?
it is the middle one. I just submitted 4 as number 1,
Middle one.
and the answer is the middle one.
Okay.
Oh, it's a middle.
All right. The X bar one, right?
Yep.
All right. Wow.
Okay, cool.
I can't
Awesome.
believe it.
Nice.
That is
That was
so
better
awesome.
than I expected.
Same.
Oh my
right.
gosh.
All right. Well,
I'll try to do my work closer next time. Closer to
Oh,
the
wait, you know
time.
what? I missed a question. What's number 11?
Number 11. $3.5.
I put 1.5. I don't know what I was thinking. Hold on. Oh, and then I missed number 8. 160, isn't it?
Number 8. Number 8
is 2.338.
Yeah.
What's the answer for number 8?
2.338.
2.338. Okay.
Wait. Number 11, you got 2.338?
No, number
No.
8.
Oh, I was going to say I got 3.5. Okay.
Yeah, and number
You put
9 is
N.
3.5.
You know, I don't know what I was doing here. And for number 3, you got... Oh my gosh, what's going on? Number 3 is 1. What do you guys for number 3?
Number 3,
Um,
I got 0.175.
Oh, I missed the point. Duh. Okay, 0.75. Okay. Oh my gosh. Well, that's not bad, huh?
No,
yeah.
that was way better than I expected.
Tori,
Perfect. Well,
what's up? Okay.
all right. Thanks,
Well, I guess we'll see you
ladies.
guys on
All
Tuesday.
right, bye.
Thank you. See ya.
Bye.